Okay, welcome to this video where we're looking at the AQA Foundation Paper 3 for all the topics on the 2022 Advanced Information List. Now, as you can see on the screen, these are all the topics on the Paper 3 Advanced Information, and you can download this in the link at the top of the description. Now, as with all these videos, I'm only going to be going over one or two types of questions for each of these topics, so you do need to do as much of your additional revision as you can, and obviously I will show you how you can go about using this channel to its full effectiveness. So let's just have a look at that now. So when you're on one of these videos, you can go into the description and you'll see just at the top there are the links for the revision checklist and also the links where you can download the free practice booklets for these. So make sure you visit that, download both the checklist and the revision papers there so that you can obviously go through this on paper and have the things like the graphs and the tables in front of you. Just makes it a lot easier than going through it on screen. So that's where you can download those. As well as that, if you click onto the video when it is paused, you can see down the bottom left there it says the name of the topic that it's on in that particular moment. Sometimes you do have to refresh the video for these to appear, but once you've refreshed it, normally they're there if it wasn't already. Now if you click onto that, you'll see either to the side or just below the video all of the chapters pop up, and you can scroll through the video and just go over the specific sections that you need to look at. You know, it might be just before the exam that you have 3 of these topics that you weren't very sure on, so you can skip through and you can watch them the day before once you've obviously gone through all of the other topics. So that's how you can go about using this video. Hopefully that's useful and helpful. Please don't forget to like the video, don't forget to subscribe, don't forget to comment and let me know how you're getting on, and please don't forget to come back and let me know how you get on with your actual GCSE results. But we've got lots to get through, so with that being said, let's get started. Okay, so looking at place value. Now in this question, to start with, it says write down the value of 7 in the number 1074. And normally as you say the number, you'll see that I say 74. So the value of that 7 is 70. So we'll just write 70, and that would be the answer for that question. For the next one, we're looking at the decimal places here because it says write down the value of the 3 in the number 16.35. And unfortunately, we don't quite say the number correctly there, but we have to think about what position it's in. And that 3 is in the tenths column. So that is 3/10. So we'd write that down as a fraction. We'd write down 3 over 10. And there we go, and that is the value of the 3, that is 3/10. Of course, if we were looking at the 5 there, that's in the hundredths column, so that would be 5/100ths. But there we go, that's looking at a little bit of place value. Okay, so there are 15 pencils in a pack and 40 pens in a box. How many packs of pencils and boxes of pens would we need to buy to have the same amount of each? So we're looking at lowest common multiple, so 15 and 40. I'm going to do a list of their times tables, so 15, 30, 45, 60, 75, 90, 105, 120. And there it is. I know that 40, 80, 120, that's going to be our lowest common multiple there. So the question said how many packs of each, so that is 1 on the top. We've got 1, 2, 3, 4, 5, 6, 7, 8. That was the pencils, so that's 8 packs of pencils. 8 packs of pencils. And below there we have 1, 2, 3 boxes of pens. Okay, so just remember to read the question there, what's it actually asking for in the final step, even though we were looking at lowest common multiple for that one. Let's have a look at the next one. So find the highest common factor of 72 and 90. So we've got different methods of doing this. We can write down 72, we can write down 90 and start finding all their factors. We can of course use the prime factor method, but let's have a look. Let's start with 90. 1 and 90. 2 and 45, 3 and 30. Let's see what else goes in. 4 doesn't go in, 5 does. 5 goes in 18 times. 6 goes in, let's have a think, 15 times. 7 doesn't, 8 doesn't, 9 does. 9 and 10, now the numbers are right next to each other, so there's no more to look at. So starting with the biggest, let's have a look which one goes in. 90 doesn't, 45 doesn't, 30 doesn't go into 72, does 18. 18 actually goes in 4 times. So 4 times 18 don't have to do all the factors of 72 there because we've spotted that it's 18. Of course, we could use the prime factor method to find the highest common factor, which I'd recommend for numbers like this, so 72 and 90. Do their prime factors, so 8 and 9, 3 and 3, 2 and 4, 2 and 2. 90 is 9 and 10. And then we have 3, 3, 2 and 5. And we can have a look at what's in both. So they both have a 2. They both have a 3, so times 3. They both have another 3, and that's all that they share. 2 times 3 is 6, times 3 again is 18. So we can get our highest common factor using our prime factor method as well. Right, so a washing machine costs £640 plus 20% VAT. James pays a £68 deposit and the rest in 10 equal monthly instalments. Work out the cost of each monthly payment. So it's a percentage of an amount question, so we need to work out 20% of 640. 10% is the most important percentage we ever have to work out, so we can work out everything from there. So we'll work out 10%. 10% is £64. 20% will be double that. So double that is £128, so that's the extra amount he's got to pay for VAT. So if we add these together, 640, add 128, we get £768. Now it says he's going to pay a £68 deposit, so let's take that £68 off because that's what he pays right at the start, and that leaves us with £700. Now it says in the question he's going to pay that in 10 equal monthly instalments. So if we finish this off, if we divide this by 10, so 700 divided by 10 tells us that he's going to pay £70 per month. There you go. So the main part here was the working out the percentage. So always work out 10%, and remember from there you can figure out any percentage. We could have halved 10%, we could have got 5% as 32, or we could have actually divided it by 10, we could have got 1%. Dividing 64 by 10, 1% would have been £6.40, and we could have built that up to any percentage that we wanted from there, so £6.40. Let's have a look at something else. Okay, some error intervals. 6.4 has been rounded to 1 decimal place, and write the error interval. So the error interval, we always tend to put either 6.4 or a letter in the middle, depending on what the question is, and we have our arrows always pointing to the left. So we're going to find the upper and lower bound. Now 6.4, if it's been rounded to 1 decimal place, it couldn't have been 6.45. As soon as that 5 goes after that 4, it would have rounded up to 6.5. So we put that on the right hand side as our biggest possible number, that it couldn't have been 6.45. So it can't be equal to that number, so we leave that symbol as it is. It's got to be less than 6.45. Now what we did there is we added on this extra 0.05, and all we're going to do for the smaller one is take that away, so it would be 6.35. okay, but it can actually be equal to 6.35, so I'm going to add my little equal to symbol on my inequality just there. So it can always be equal to that lower bound, because that would in fact round up to 6.4 if we rounded it to 1 decimal place. On to the next one. This one's slightly different in the wording, so this one says it's been truncated to 1 decimal place, and truncated basically just means it's been chopped off at that after this first decimal, regardless of how it rounded. So if we have a look at writing this as an error interval, again we write these in the same way. The impossible number that it couldn't have been 6.5. So my top one here is 6.5. It had to be 6.4 something if it was just chopped off. Let's imagine just a random how this works. So it could have been 6.4932, but it was just chopped here and we just wrote what was at the start. Okay, but it couldn't have possibly been 6.5 because otherwise we'd have written 6.5. And the smallest it could have been is just 6.4 with no digits after it. It couldn't have been 6.3 though, because again, if we truncate that, it would have just been 6.3. So two different scenarios there. One where you've got to add on that extra 5 at the end and take the same size 5 off the start, and truncating there where we've just got to think about the fact that it was just chopped off and no rounding at all. And the final little one we're going to have a look at here is using your calculator. So it's important to know where lots of digits are. Pick quite a complicated one here, but you just need to have a play around with your calculator to make sure you can find your square root, your cube root, your squared, your cubed, your fraction button, your sin, your cos, your tan, and figuring these out. So I picked quite a complicated one here. So to get your cube root button, depending on what calculator you have, but the majority of them you still have to press the same things. We press shift and then we go for, let's get a different colour here, we go for the square root button, and that allows us to get a cube root. So on your calculator, a cube root will pop up, and then we're going to use the fraction button. So the fraction button is just next to it in this diagram here, the fraction button, and an empty fraction is going to pop up. So on the top, we're going to just type in on the top of that fraction there, 4.3 multiplied by, press your tan button, and then press 39, and normally this will go in a bracket, so remember to close the bracket off there. But you don't put this little degrees symbol in, you just put 39, the calculator knows that you're talking about degrees. So let's get that up on my calculator. We've got 4.3 multiplied by tan, the brackets opens for me, 39, close the brackets, press your down button on the calculator to go into the bottom of the fraction, and type this sum in here, 23.4 take away 6.06. So 23.4 take away 6.06, and make sure at this point you write all the numbers down. That equals 0.5855934233. Now some calculators may go beyond this depending on what the answer is on the calculator, but it tends to be that you never really have to go beyond 9 digits because not all calculators will go that far, so you are limited to the amount that some people will be able to write depending on what calculator they use. Now the question will probably usually say then to round your answer to 1 or 2 decimal places, so if we just have a quick think, if we were to round this to 1 dp, to 1 decimal place, and we could chop that after the 5 there. So 1 decimal place would round up to 0.6, and we would round that to 0.6. If we had this to 2 decimal places or beyond, let's have a think. After 2 decimal places, let's pick a different colour. It would chop it after the 8, and it would be 0.59 because it's a 5 after that one. Okay, so you could have different ways of rounding this, but just make sure you write down all the digits on your calculator display before actually rounding anything. Okay, so looking at some money calculations with time. It says James works in a restaurant and the table gives his rates of pay. So we can see Monday to Friday he earns £8.40 per hour, and at the weekend he earns £11.20 per hour. So it says here James worked for 20 hours last week. He worked 8 of these 20 hours at the weekend, show that he was paid less than £200 last week. Well, we want to start by working out potentially the amount that he was paid for the weekend hours. So for the 8 hours he worked on the weekend, he would get £11.20. So if we multiply that by £11.20, we'll just type that in on the calculator. 8 times £11.20 comes out as £89.60. So at the weekend he earned £89.60. That means the remaining hours he worked Monday to Friday. So if he worked 8 of the 20 hours at the weekend, that leaves him with 12 hours that he worked during the week. So for those 12 hours that he worked, he was paid £8.40. So we've got to work out 12 times £8.40. So if we type that in, 12 times £8.40, that comes out as £100.80. So you can already see there that that's going to be less than £200, but it does say show that James was paid less than £200. So we want to make sure we show the working out for this. We do £100.80, and we add to that £89.60. And again, we can just type that in on the calculator, and that comes out as £190.40. So there we go, that is £190.40, and we've shown there that he was paid less than £200. Okay, so looking at length conversions. Now you need to know the conversions here, so we'll just go through a few of these. For part A, it says change 265 centimetres into metres. So you need to know that in every 1 metre, there are 100 centimetres. So that's the fact that you need to know. So to convert 265 centimetres into metres, we would divide that by 100, as there's 100 centimetres in every 1 metre. And that comes out as 2.65 metres. So that'll be our final answer for part A. For part B, it says to change 4.7 kilograms into grams. So you need to know that in every 1 kilogram, there are 1,000 grams. So there we go, in order to convert between them, we'd multiply or divide by 1,000. In this case, we are converting the kilograms into grams, so we're going to get a much larger number, and that is, to do this, we're going to multiply by 1,000. And if we multiply by 1,000, that would be 4,700 grams. And there we go, that is converting kilograms into grams, and of course the other way around, we would divide by 1,000. For the final question here, we're converting millimetres cubed into centimetres cubed. Now you need to know for this that there are, in every 1 centimetre, there are 10 millimetres. So to convert between centimetres and millimetres, we'd multiply or divide by 10. Now, in order to get between millimetres cubed and centimetre cubed, rather than timesing by 10 or dividing by 10, which we would do here, I'm just going to write this down like this, so we would divide by 10 going that way, times by 10 going this way, but when it is a centimetre cubed to a millimetre cubed, instead of dividing and timesing by 10, we divide by 10 cubed and times by 10 cubed. And the same theory applies there. If we're moving between centimetre squared and millimetre squared, we would divide by 10 squared and times by 10 squared. So for this one, we're moving from millimetres to centimetres, so we are going to divide by 10 cubed. So to do that, type it into your calculator and we get 2.4, and that is centimetres cubed. And there we go, that's our final answer. Okay, so looking at some function machines. Now here the number machine says that when you put the input in, you multiply by 3 and then take away 4 and we get the output. So for this first question where it says work out the output when the input is 4, well if the input is 4, when we times it by 3 it becomes 12, and then when we take away 4 that becomes 8. So for the first one there our answer will be 8. For the next one, it says work out the input when the output is 11. So if we put the output as 11, we'd have to work backwards. So what was it before we took away 4? Well, to work that out, we can add 4 going backwards. So it must have been 15 before we took away 4. For the next one, it says it was obviously multiplied by 3. So to go backwards through that, we would divide by 3. So what was it when we divide that by 3? We get an input of 5. And the good thing about this, you can check it again going forwards. So 5 times 3 is 15, add 4, take away 4, which was the original function machine there, which gets us to 11. So that works, that must have been an input of 5. Now this final question here is a little bit more complex. So it says, show that there is a value of the input for which the output is the same as the input. Or in other words, if we put in 10, we get out 10. Now obviously that's probably not the case for 10, that was just a random guess, but we have to work out a number which gives us the same output. Now there are two ways of doing this. Of course you could just guess a number, so we could say, okay, well if we put in 1, what do we get? Well, times that by 3 is 3, take away 4 is minus 1. So 1 doesn't work, and we could just build up from there. And it might just be that you get it on the second or third guess, but you could also approach this using algebra. We could say, well, if we put x in, what do we get on the outside? We need to get an output of x. So when you times that by 3, you get 3x, and when you take away 4, you get 3x minus 4. And I want that to equal x. So I could write an equation like this, 3x minus 4, and that has to equal x, which was the input. And we could solve it from there. I'm going to show you both ways, because actually it's not too bad to do a trial and error method on here, but this will work no matter what. So when you've got x's on both sides, you have to take away the smallest x. So if we take away x from both sides, you get 2x minus 4 is equal to 0, as we've taken away an x from both sides. If we add the 4 to the other side, again you have to know solving equations for this, 2x is equal to 4, and then divide by 2, you get x equals 2. So as it turns out for this question, it would have only taken me, 2 goes if I started with 1 to find that x is equal to 2. Because obviously after 1, I'd try 2, I'd times it by 3, which would give me 6, I'd take away 4, and I'd get 2. And I'd have got the answer pretty quickly there. But if the input that we were looking for was, say, 10, it might have taken me quite a long time to get there. So obviously having this method of solving equations is very handy for this. But there we go, 2 different methods that you could use to approach a question like this using number machines. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1, which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. Got two slightly different ones here that look almost the same because we've got some fractions going on, but let's see how we treat these ones. So on this left, make x the subject. So again, what I could do is I could get rid of this 3 on the bottom to start with if I wanted, or I could get rid of this 5. I'm going to decide to get rid of the 5, so let's take away 5 from both sides. So if we take away 5 from both sides, we get y minus 5 equals x over 3, or x divided by 3. So to reverse a divide by 3, we're going to have to times by 3. So if I multiply both sides by 3, we'll get 3 lots of, and I'll put it in a bracket now, 3 lots of y minus 5 equals x. We could leave it like that, or we could expand this. We could say 3 lots of y is 3y, 3 lots of 5 is 15, copy the symbol, and then put in our x. Again, we could have done that a slightly different way. We could have times by 3 to start with. You'd have just had to remember at the starting point we'd be timesing this by 3, and we'd be timesing this by 3, just like we did in the end there. But that's our final answer. Now looking at this one on the right, it's slightly different because we don't have the option of getting rid of this 5 on the starting process here, because it's locked in by this divide by 3 on the bottom. So the first thing I'm going to have to do is times by 3 to remove this fraction to unlock what's on top there. And if we times by 3, we get 3y equals, and what's on the top is x plus 5. Now we can finish it off quite nice and easily. We can just take away that 5, and again that's going to make x the subject, so we have 3y minus 5 equals x, and again both of these questions we could rewrite it as x equals at the start if we wanted. So a equals 5b plus 2c, b equals 3 and y equals negative 2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket, so we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of negative 2. We put these in a bracket like that. All we have to do is now multiply these. So 5 times 3 is 15. 2 lots of negative 2 is negative 4. And we're adding these together. So 15 add negative 4 is 11. Remembering that these just become a takeaway. So it's 15 take away 4. So a would equal 11. There you go. Just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. So in this question, we're looking at roots and turning points. Now it says here is the graph of, and it gives us the equation, y equals x squared minus 2x minus 4. Write down estimates for the roots of, and when we've got x squared minus 2x minus 4 is equal to 0. Now when a quadratic is equal to 0, that is effectively ground level. It means where does the graph cross the x-axes, and where it crosses are called the roots, and it can also be called the solutions. So we are looking at, and I'll draw it on the graph, this point here and this point here, and they are called the roots and also known as the solutions. So in this question they've used the word roots, and it says estimate because obviously you can just about see it on this graph, so it's not the clearest, so you're just giving your best estimate. Now that one on the left there, from what I can see, looks like minus 1. So I would say x is equal to minus 1. For the one on the right, it's just over 3. So as it is just over 3, I'm going to say 3.2. It looks like it's just crossing the square just afterwards, and it's 5 squares between 3 and 4, so I'll also say x is equal to 3.2. Now the really nasty versions of this question, rather than saying equal to 0, it would say something like equal to 8. And if it wanted to know where it equaled 8, I'd draw a new not an x-axis, but a new line through 8, just like the x-axis, and I'd read the points here and read the points there. But that's a lot nastier version of the question, but could be asked potentially as well. Part B here says write down the coordinates of the turning point, and again it's the same equation, so we are looking at the point where it turns, which is the point where it stops going down and starts going up. It's the lowest point on the graph, or if the graph was a negative x squared graph where it's shaped like an n instead, we'd be looking at this point right at the top of the graph. But we're looking at the point right down the bottom there, so I just need to read that coordinate, and if I trace up very carefully you can see the x coordinate is 1, so if I write my coordinate, I'll put 1 as the x coordinate. I'm going to go to the left and read this coordinate here very carefully, and that looks like -5. It's between -4 and -6, so it's 1 and -5. And there we go. That is how we approach roots and turning points. So find an expression in terms of n for this sequence. So we're going to do the nth term, and then it says hence find the 50th term. So what I always like to do is draw these little loops just to see what times table this is related to, and from 3 to 7 it goes up by 4, and then it keeps going up by 4. So this is related to the 4 times table. Now the expression for the 4 times table is 4n, if we do it in terms of n. Now this is obviously not the 4 times table though, is it? Because the 4 times table, if I write it above, is 4, 8, 12, 16, 20. And all of these numbers are 1 less. Look, from 4 to 3 is -1, from 8 to 7 is -1, so it's the 4 times table, but it's had 1 taken away, and that is our nth term there in terms of n. There is also a little trick that you can apply on this. You can go backwards 4, so if we go back 4, we get the number -1, and that always tells us how much smaller or how much bigger it is than the times table we're looking at. So it says hence find the 50th term. Well, here's our little code, 4n minus 1. To find the 50th term in the 4 times table, you do 4 times 50, and it's no different for this one, but it's the 4 times table take away 1. So we're going to sub it in, and we get 4 times 50, or 4 lots of 50, but then we have to take away 1. 4 lots of 50 is 200, and 200 take away 1 gives us 199, and that is our 50th term. Just thinking, if you didn't have this nth term, you'd have to just keep counting up from 19, so you'd go 23, 27 and so on, and you'd have to keep counting up to the 50th term, and it'd take you quite a long time, so this is a nice little shortcut for that. Here's another one, find an expression in terms of n for this sequence, and then will 84 be in this sequence, explain your answer. Let's have a look. It's going up in 5s, so our expression for the 5 times table is 5n, but this is not the 5 times table because the 5 times tables goes 5, 10, 15, etc. So 6 is 1 bigger, 11 is 1 bigger, so it's the 5 times table, but it's got 1 added on, so that's my nth term this time again. We could have gone back 5, which would have given us the number 1, which is a positive one, and that's just another way that we could have a look at it. Now it says, will 84 be in this sequence, explain your answer. Now there's 2 different ways of doing this. This one in particular I'd like to use more of a logical approach. So if you have a look at all these numbers, 6, 11, 16, 21, 26, they all end in 6 or 1. So I would be able to say no, because all the numbers end in 6 or 1. Okay, because they all end in 6 or 1. But there is another way of doing this. There we go, they all end in 6 or 1. Okay, so that's option 1. There is another way, because it might not be that there's a pattern, so my second option is I can actually just make an equation. I can just say, well, does 5n plus 1, does it ever equal 84? And that's what that means there. Does 5n plus 1 ever equal 84? And we can solve that. So taking away 1, we get 5n equals 83. And then if we divide by 5, we get 83 divided by 5, which is not a whole number. So I could say no, n's not going to be a whole number, the position is not going to be a whole number. Okay, so not a whole number. And I would obviously just have to make that statement. No, not a whole number. Find the nth term expression for the sequence, and we've got 4, 20, 100 and 500. Now when it comes to a geometric sequence or geometric progression, what we need to have a look at is what we are multiplying each term by to get to the next one. And there's quite a simple way of doing that. You just take the bigger term and divide it by the smaller term before it. So what I mean by that is obviously looking at these first 2 here. If we do 20 divided by 4, that gives us the answer 5, so that means we must be multiplying by 5 each time. Although, as with any sequence, always just double check and make sure. So that is being times by 5, and then for the next one as well, 20 to 100, that is also being times by 5. So there we go, we've figured out what we're multiplying by each time. Now, writing an nth term for this is a little bit different to normal nth terms. It's very different to linear nth terms, and it's it's very different as well to quadratic nth terms. Now, I like to link this back to something that hopefully you already know about, and that's compound interest. Now, if you take this as an example, if we have £1,000 in the bank, okay, and we're getting a 3% rate of compound interest, and again, hopefully you're okay with compound interest. If not, then obviously have a look at that in my percentages playlist. But when we're multiplying for compound interest, if I was to get 3%, okay, I would multiply by, for the next year, 1.03, okay, and in the next year I would have £1,030. Don't mean to write a zero there, £1,030. And then again for the next year we'd do the same, and we'd multiply by 1.03 again. And if I just work that out on my calculator, I get, let's have a look, £1,060 and 90p. There we go, £1,060 and 90p. And that right there is a geometric progression in itself. Okay, we're starting off with 1,000, we multiply it by 1.03 each time to get each next number in the sequence, and then again we can then go about creating the sequence. Now, in terms of how we go about doing the compound interest, and again hopefully you are well versed with the compound interest, but I would get the starting amount, which in this case is the £1,000, okay, and we would write this down in the calculator. I'd write in 1,000, and I'd write down times 1.03, and we put that to the power of whatever year we're on. Now, what I mean by that in terms of whatever year we're on, obviously in the second year, obviously this is our first year here where we start with 1,000. At the end of the second year, we would have times that by 1.03 to the power of 1, okay, to get to that second year. When we get to the third year, okay, or the end of that period of time, which is actually the end of the second year, start of the third year, it would have been times 1.03 to the power of 2, okay? So just thinking about what we would do there, to get the start of the third year, I would have done 1,000 times 1.03, but only to the power of 2. Okay, it obviously gives me the amount at the end of the second year, which is at the start of the third year. And this concept, this idea, is how we apply this to the actual nth term for the geometric sequence, okay? We take our starting number, which in this case is 4. Let's just do this to the side. 4. I write what I'm timesing it by, just like with compound interest, we times it by 1.03. In this circumstance, we're timesing by 5. And then I need to write my n number in terms of a power, in terms of the amount of years, like below. So I would write 4 times 5 to the power of n, but if you notice again, the second year the power was 1, the third year the power was 2. It's always 1 less than the actual position it has in the sequence, so it's n minus 1. So I start with 4, I times it by 5, and do that to the power of n minus 1. And if you have a look at my little sequence just up here, 4 times 5 to the power of, and look for the second number there, which is 20. 4 times, let's just write this in fact, we'll test it out, let's have a look. So for the first one there, we've done 4 times 5 to the power of 2 minus 1, okay, for the second one. And that is 4 times 5 to the power of 1, which is 4 times 5, which gives us 20. The next one, the 100, we could have done 4 times 5 to the power of 3 minus 1. There you go, for that third number in the sequence. And that would be 4 times 5 squared. And 4 times 5 squared, well, 5 squared is 25. 4 times 25 is 100. So there you go, you can see that it works, okay? But really, all we've got to do, we get the starting number, just like we do in compound interest, our £1,000, in this case our 4. You multiply it by whatever the actual term is being multiplied by each time, which is called our common difference, or our common ratio there. We're timesing it by 5, so we put times 5, and then you just put to the power of n minus 1, and it's always the power of n minus 1 there, other than a few little scenarios which we'll look at later in the video. But there we go, that's how we go about it. Again, hopefully that's nice, just linking that back to compound interest for you as well. So you can see obviously a little bit of linkage here with another subject, another topic that we've looked at. Okay, so looking at one of these length problems where we have fractions and ratios involved as well. So it says here we have a rectangular wall, and you can see over here it's 6 meters by 1.8 meters. It says Frank is going to cover the wall with rectangular tiles, and each tile is 60 by 30. 3/5 are going to be white, some will be green, the rest will be blue, and the ratio of green to blue is 1 to 3. So we've got 3/5 that are going to be white, and then green to blue is 1 to 3. Assuming that there are no gaps between the tiles, how many tiles of each colour will Frank need? Well, we need to work out how many tiles can actually fit on this wall. And one of the measurements is given to us in centimetres, and over here on the diagram they're given to us in metres. So what we could do is we could convert them. So I would probably write this one as 600 centimetres and 180 centimetres. Obviously just timesing both of those by 100 to turn them into centimetres. Now if we look at the tile, which is 60 by 30, we could think quite logically about how many would fit across. So if the tile, and obviously this isn't drawn to scale, is 60 across and 30 going up, or you can swap it around the other way, in terms of the 60 in relation to the 600, that would mean we could fit 10 tiles going across. Okay, because 10 times 60 would be 600, so we could fit 10 tiles going across. From the 30 to the 180, that's a multiplication of 6. 6 times 30 is 180. Obviously you could type that calculation in on your calculator, 180 divided by 30, but then we know that there's 6 tiles that could fit going up. So there are 10 tiles that can fit going across, 6 tiles that can fit going up. So in total that would be 6 times 10, and that is going to be 60 tiles in total that will fill this wall. So now we know how many tiles there are going to be in total, we can actually start to break it down, look at the fraction, and then look at that ratio. So it says 3/5 are going to be white. So if we work out 3/5 of 60, that's going to tell us how many of them are going to be white. So to work out 3/5, we'd first divide by 5. So 60 divided by 5 is 12. And then we want to times that by 3 because we want 3/5. So that is going to equal 36, and that is the white tiles. So now we know how many white tiles there are, we can start to figure out how many of them are going to be green and how many of them are going to be blue. So the number of green to blue is in the ratio 1 to 3. Well, out of the 60 tiles, we already know that 36 of them are going to be white. So if we do 60, take away the 36, that's going to tell us the total, they're going to be green and blue. So 60 take away 36 is equal to 24, and 24 is now going to have to go in the ratio 1 to 3. So in total, there are 4 parts in that ratio. So if we want to label this up as a ratio, we've got green to blue. It's going to be 1 to 3. There we go, so 1 to 3. So if we divide the 24 tiles by 4, we know that each part is worth 6. So if we multiply both of those by 6, that's going to be 6 green tiles and 18 blue tiles. So there we go, we know that there are going to be, I'm just going to write the letter, so 36 white, there are going to be 6 green, and there are going to be 18 blue, and that'd be our final answer there, 36 white, 6 green, 18 blue. Obviously add those up and they also equate to 60, so we know we've got the full amount there. So there we go, that's how we'd approach one of these problems. Okay, so the other way around, a house rises in value by 3%. The value of the house increases by 7,500. Work out the value of the house before the increase. So when it's been increased in value, again, we can visualise this. We've got the original price, which is our 100%, and then it's rising in value by this extra little 3%. So again, identifying what is this 7,500? Is it the original 100% or is it the 3%? Now it says it rises, it increases by 7,500. So that 7,500 is my 3%. There you go, and again we want to know 100%. I can't straight away times 3 to get to 100, but I can divide both of these by 3 to find out what 1% is. And again, we can do that on a calculator or using Better Bus Stop, but 7,500 divided by 3 is 2,500. So 2,500 equals 1%. And again, we can times that by 100. So over here, if 1% equals 2,500, we can times that by 100 to get our 100%. So 100% will equal 2500 with another 2 zeros, and that's 250,000. So our answer there would be £250,000. Okay, so it says here, write the following numbers in ascending order. Now ascending order means smallest to biggest. So we need to find out which of these is the smallest, which is the biggest, and put them in order. Of course, at the moment we have a decimal, we have a fraction, we have a percentage, another fraction, and another decimal. So it's not very nice to order them as they look. So the best thing to do on a question like this is to turn them all into the same format. Now, you might have noticed on the previous questions, but with all of them we used percentages. So personal preference for me, I like to write them all as a percentage. So first of all, why don't we just try converting them all into a percentage? Of course you could try something else here, but I do think the percentages are the much easier way in order to do this. So for the first one, 0.30, and of course don't forget you can put a 0 at the end there, because then when we multiply that by 100 it gives us 30%. So our first one is 30%. For the second one, we want to turn that into a fraction over 100. Of course, if you just know this already, then that is fine, but 1 over 4 would become 25 over 100. So that one there is 25%. Of course, if you just know that, that's fine as well. You don't have to show the working out for that as long as you're confident with it. Now the third one is already written as a percentage, so that's nice and easy, 28%. The next one's a fraction. So again, let's think about how we would turn that into a percentage. 6 over 25, we would want to multiply the top and bottom by 4 to make it over 100, and 6 times 4 is 24. So that becomes 24%. And then for our final question here, or our final part of this question, we've got a decimal. So if we times that by 100 and we hop the decimal, it's going to jump over the 9. So that is going to become 29.5. And there's our first part where we've had a decimal inside our percentage, but that's fine as well, it's just 29.5%. So let's get rid of our working out and then let's think about which one of these is the smallest, and then we'll put them in order. Now when you're doing this question, it says write the following numbers in order. It doesn't say to write these percentages in order. So we do have to write the original parts of the question in the appropriate order. But before we do that, I'm going to order them from the smallest. So hopefully you can spot 24% is our first smallest number. We then have 25%, which is our second. Then we have 28%. Then we have 30%. And then actually, I've missed out the 29.5. Our fourth smallest was definitely the 29.5%. And then we have our 30%. So as you've just seen, always be very careful and check that you've read all the numbers carefully. So now we've got that done, let's just write the original parts in order. So the first one was the 24%, and that was 6 over 25. The next one was the 25%, and that was 1 over 4. The next one was 28%, and that was already a percentage, so that's fine to leave it. The next one was the 29.5%, which is 0.295. And the final and biggest part was the 0.3. And there we go, we've written them all in ascending order using our conversions. Okay, so share £240 in the ratio 5 to 7. So if we're splitting this in a ratio, let's have a look. We've got in total here 5 plus 7 equals 12 parts. Okay, so if we split this into 12 parts, we could do 240 and divided by 12. And 240 divided by 12 is 20. So in each part there's £20. Now there was 5 parts and 7 parts, so those 5 parts are going to be 5 lots of 20, which would be £100, and the other part there was 7 parts, and that times 20 would give us £140. So splitting it in the ratio 5 to 7 gives us 100 to 140. And the last little check you can do here is just to add these two together, just to make sure you do get that £240 that you started with. So we're happy with that as a final answer. So Craig and Ian share some money in the ratio 8 to 3. Craig receives £32. How much does Ian receive? Well, C to I, Craig to Ian, was in the ratio 8 to 3. And it said that Craig receives £32. So that is this first number 8 here, that is 32. So what we've got to think about is how do we get from 8 to 32? So 32 divided by 8, which we can do to the side, 32 divided by 8 is 4. So we must have times by 4 to get there. So if we do the same to the other side, times by 4, 3 times 4 is 12. So there we go. How much does Ian receive? Ian receives this 12. So I'll just say £12. Final answer. So Emily and James share some money in the ratio 4 to 7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4 to 7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them. So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go, so they share £77 between them. A to B is in the ratio 3 to 5 and B to C is in the ratio 2 to 1. Work out the ratio A to B to C. So if we write out A to B to C and start to write what we've got so far. Now it says A to B is in the ratio 3 to 5 and then it gives us B to C. So there's an overlap in these, there's a B in both. So I can't put another number just over the top of the 5, so I'm going to start a new level. I'm going to write the other one underneath. So B to C is 2 to 1. Now looking at this, if I can make these middle numbers the same, I can merge these ratios together, I can squish them together essentially. So let's think, 2 and 5 can make 10. So if we times the top one by 2, that would make that 5 a 10, and we'd have to times the bottom one by 5. So if we times the top one by 2, that 3 becomes a 6, and the 5 becomes a 10. Looking at the one below, timesing that by 5, 2 times 5 makes 10, which we've already got in the middle, and 1 times 5 is 5, and there's my ratio A to B to C, 6 to 10 to 5. Just have a look to see if you can simplify in any of these questions, but it doesn't actually ask us to simplify it there. Okay, so again, there's nothing more complicated in this question, it's just there's a little bit of different wording going on. So it says Maria, Dylan and Kate share £3,000. The ratio of the amount that Maria gets to the amount that Dylan gets is in the ratio 5 to 4, and Kate gets 1.5 times the amount that Dylan gets. Work out the amount of money that Dylan gets. So we want to have a look, how are we actually going to create this ratio? Because at the moment we've got Maria, we've got Dylan and we've got Kate, but it only tells us the ratio, and that's, so let's just highlight that. Dylan and Maria, or Maria and Dylan, 5 to 4. So we've got 5 to 4 for Maria and Dylan, but we don't know how much Kate gets in terms of parts of the ratio. But it does then say Kate gets 1.5 times the amount that Dylan gets. So Dylan gets 4 parts, so if we times that by 1.5, that actually gives us a value of 6. So Kate is getting 6 parts. Remembering multiplying by 1.5, if you don't have a calculator, just adds an extra half on. Half of 4 is 2, add it on gives us 6. So now that we've multiplied that by 1.5, the rest of the question's nice and easy. Because all we're going to do now is split that £3,000 in the question in the ratio 5 to 4 to 6. So if I get rid of this little bit of working out, this times 1.5, let's have a look. In total, that ratio adds up to 15 parts, and now we know that those 15 parts equal the £3,000. So we can find the value of 1 part again by dividing by 15, and 3,000 divided by 15 gives us a value of 200. There we go. So they all get 200. So we can go about timesing them all by 200. We're actually only concerned about Dylan in this particular question, and Dylan gets these 4 parts here. So we can just answer that straight away. Dylan's 4 parts, each one of them's 200 quid. So 4 times 200 gives us £800 for Dylan. There we go, and there is our final answer. And again, you could go about obviously finding out the amount that they all get. We could do Maria times 200, which is 1,000, and Kate's times 200, which is 1,200. And you could even add them all together then and show that there's £3,000 there. But that's how we'd approach a slightly different question here. We've got to think about creating the ratio slightly ourselves. The car has to travel 30 miles along a motorway in 24 minutes. Will the car have to travel faster than 70 miles an hour to get there in 24 minutes? Now I'm going to do this as a non-calculator one, then we'll have a look at one that's maybe a little bit more calculator based. But if it has to travel at 70 miles an hour or more, now 70 miles an hour means that we go 70 miles in 60 minutes. So 70 miles equals 60 minutes. Now what we can do is we can actually start to break this down. So if I have a look, what can I divide both sides by? So if I can divide both sides by 10, that would mean I would go 7 miles in 6 minutes. Okay, dividing that by 10 as well. So you can have a look to see if you can ever break these down this way. So 60 divided by 10 gives us 6 minutes. There we go. Now it says we've got to go 30 miles and we've got to go there in 24 minutes. Now just having a look at this speed here, 7 miles equals 6 minutes. So travelling at this speed, If I wanted to get to 24 minutes, have a look, 24 minutes, we would times that by 4. So if I do the same to the other side and times that by 4, that gives us 28 miles. So travelling at 70 miles an hour, in 24 minutes we would go 28 miles. And the question said a car has to travel 30 miles. So it's not actually going to be able to make that 30 miles in 24 minutes. It's only going to be able to go 28 miles. It would have to go over 70 miles an hour. So I would make obviously that statement no. Okay, it's only going to go 28 miles, or it's not going to be able to do it in that sort of speed. David travels from Birmingham to Glasgow. He drives at an average speed of 70 miles an hour for the first 3 hours, and he then drives an extra or a further 150 miles at an average speed of 30. Work out his average speed from Birmingham to Glasgow, so for the whole journey. I'm going to take a similar approach as I did to the density question here, but I'm going to think about obviously using my formula now. So I want to write down my formula, which is speed equals distance over time. And again, we can put that into a formula triangle if we want, and I'm going to do that. So speed equals distance over time. So speed, distance, time. I'm going to use a little formula triangle. So let's see if we can tidy up what we've got here in a little two-way table. And again, for each one, we're going to need a speed, we're going to need a distance, and we're going to need a time. Now we've got the first part of the journey, the second part of the journey, and we've got the total journey. So let's split this all up and write in what we've got so far. Okay, so at the moment he drives at an average speed of 70 miles an hour for the first 3 hours. So this first one here is 3 hours, and he drives at a speed of 70 miles an hour. The second part, it says he drives 150 miles, which is a distance, and he drives at an average speed of 30 miles an hour, so that's going to go just above there. And we want to work out essentially the average speed for the whole journey, which is this one just here. Now again, we can't join together speeds, it's going to be somewhere there in between the 70 and the 30. So let's have a look at what we can do. So this first distance here, let's see if we can work that out. So looking at our formula triangle, distance is speed times time. So we can do speed times time to work out that distance. So 70 times 3, the speed of 70 times 3, says it will go 210 miles. So again, we can add these together to get a total distance at the end there, because that would be 360 miles in total that he's got to do. So all we've got to do is get this total speed here, this total time, and then we'll be able to work out his speed. So looking at this bottom one here, which is the time for the second one. So to get time, you do distance divided by speed. So distance divided by speed will be 150 divided by the speed of 30, which gives us a time there of 5. So that means in total he's going to be driving for 8 hours. Now we can work out his total speed, because we've got his total distance and his total time, and speed is distance over time. So it's 360 divided by the total time of 8 there, and 360 divided by 8 gives us an answer of 45 miles per hour. So I'll just write that down, 45 miles per hour. Again, keeping it all nice and tidy in a table so it all makes sense. Okay, so we've got a little bit more to this question, and as you can see, there's quite a lot of information. So again, let's just have a little read. It says Julie drove from her house to the airport. She waited at the airport and then drove home, and this is her distance time graph. So you can see obviously it looks very similar to the previous ones. So for part A here, it says what is the distance from Julie's home to the airport. So that part there we can read nice and easy. We've got the top part here, and we're going to read that distance, which we can see is 40 kilometres. So we'll write that as 40 kilometres, and again, all these questions are in kilometres, but do make sure that you read the axes because it does say the distance in kilometres. Again, this question here is about the time of day rather than minutes down the bottom, so we actually have to interpret the time. It then says how many minutes did Julie take to get home from the airport. So in terms of getting home from the airport, that's not about the time that she waited, but it is about this distance here, or this journey here. And you can see that when she left the airport, we can get the time, and that time is just down here, that's 3:30. So that's the time that she left the airport, and obviously at the end of the journey, she gets home at 4 o'clock. So in terms of how many minutes it took for Julie to get home, that goes from 3:30 to 4, and that is half an hour. So in minutes, that would be 30 minutes. Again, reading the question carefully, it does say how many minutes, not just how long, so you do have to give that in minutes and not saying half an hour. It then says for part C, and this is our new part here, it says work out Julie's average speed on her journey home from the airport. Give your answer in kilometres per hour. So in terms of working out an average speed, we need to remember our speed distance time formula. And we have all the information already in order to work that out, we just need to be careful when we're using it. So our speed distance time formula is that speed is equal to distance over time. And remember, if you like, you can put that into a formula triangle. So if I write the formula triangle over here, that is that speed is equal to distance divided by time. Now we need to be careful on this question because it does say to give it in kilometres per hour. And for the previous part, we just wrote down that the time was 30 minutes. And when we are working with kilometres per hour, we need to make sure we write that in terms of an hour. So we'll discuss that in just a second. But let's think about the two bits of information. So we need the distance. Now the distance at that point on the journey, we've actually already written down. We've got that that was 40 kilometres. So we know we're going to do 40 and we're going to divide it by the time. And the time we have already got as well. We have got the time from this part of the journey down here, which was 30 minutes. But we need to write that in hours. Now this is not a nasty amount of minutes to write in hours because you should hopefully know that that is half an hour, which can be written as 0.5. But if you are struggling on one of those, particularly if it's a harder amount of minutes, then you need to know how to turn that into an hour. And the way to do that is just to write it as a fraction. So we think about an hour, which is 60 minutes in total, and here we have 30 minutes. So that is going to be 30 minutes out of 60 minutes. And if you type that into your calculator, it comes out as 0.5. Now for these questions, you can use a calculator to do these conversions, but just be aware that sometimes, potentially with a 0.5, that's going to be potentially a question that would be non-calculator. So you do need to know how to convert some of the easier ones, because you could simplify the fraction, which would become 3 over 6 and then 1 over 2. So it's not too bad to turn that into an hour. But for this one here, we need to do 40 divided by 0.5, and that is going to come out as 80. So we have an answer of 80, and that is in kilometres per hour. So we would write kilometres and then /hour, kilometres per hour. And that would be our final answer. Okay, so looking at a question where we are describing shapes. So it says Robin is describing a shape to her friend Lily. Robin says the shape has 4 sides and it only has 1 pair of parallel sides. What shape is Robin describing? So obviously you need to know your shapes very well here. It's got 4 sides, so it's a quadrilateral. So you just need to think about drawing some of the shapes and thinking about if it matches this criteria. Now for this one here, 1 pair of parallel sides, that is only one possible shape, and it's a trapezium. So a trapezium looks like this. We've got the parallel side on the top and the bottom, but the other pairs of sides are not the same. And obviously you can also have a right angled trapezium as well, where it looks something like this. We've got a couple of right angles, but we also have just 1 pair of parallel sides. So for the shape that we are describing for this one, we're looking at a trapezium. So there we go, we would write a trapezium. Now the second one here is a bit of a strange question. It says Lily says the shape has 4 sides and it has 2 pairs of equal opposite sides, and the opposite sides are parallel. Now this is a bit of an ambiguous question because of the way that it's phrased. So we could think about the most obvious ones, which is a rectangle and also a parallelogram. Now a rectangle and a parallelogram have 2 pairs of equal opposite sides. You've got the top and the bottom on a rectangle, which are parallel, and you've also got the sides, which are equal and opposite as well. And that falls true with the parallelogram. You've got the top and the bottom, which are parallel and equal, and then you've got the sides, which are also parallel and equal. So to be fair, based on however you read this, maybe there's only 2. But we're going to discuss this a little bit further. Because also you have a square and you have a rhombus. It's a little bit harder to draw a rhombus and not make it look like a parallelogram, but they have exactly the same properties. You've got 2 pairs of equal opposite sides and the opposite sides are parallel. But this wording, 2 pairs of equal opposite sides, could be that the 2 sides are opposite, but not all 4 are equal as well. So with a square and a rhombus, all 4 sides are also equal as well. So they do have 2 pairs of equal sides, but actually all 4 are equal. So for this particular question, you could actually say yes or no, just because of the way that it's phrased. But you would have to obviously explain that. So you could say yes, because a rectangle and a parallelogram have 2 pairs of equal opposite sides, but you could also actually say no, because actually a square and a rhombus do as well. But it just depends on how you read that question. So it's a bit of a strange one. I'm just going to say yes. So I'm going to say yes, and we're going to say a rectangle and a parallelogram. But just a note on this one that, to be fair, because the wording of this is a little bit strange, you could actually make the argument of no and say that there's also a square and a rhombus. So a little bit of a strange question there, but there you go, one for you to have a little think about. Okay, so a question thinking about rotational and lines of symmetry. So it says here is a quadrilateral, write down the order of rotational symmetry of this quadrilateral. So the order of rotational symmetry means if we were to rotate it, normally around the centre, so around this central point, how many times would it take to turn it back to its original position? But along the way, are there any points where it would look exactly the same as we turn it? So obviously as we turn it 90 degrees, you would end up with this quadrilateral in this position here. So it doesn't look perfectly the same, so that wouldn't count. As we get round to 180 degrees, it would look exactly the same. So it would get to this point, and that would be an order of 1 by that position. If we rotate it another 90 degrees, it would go back to this position, this first one, so that wouldn't be the same. And then we rotate it one more turn of 90 degrees, and it gets back to its original position. So it would have an order of rotational symmetry of 2. Once where it gets to basically upside down, and then the final turn where it gets back to its original position. So we have an order of rotational symmetry of 2. And therefore any shape, if you think about this, any shape is always going to have an order of rotational symmetry of 1, because it will always go back to its original position. So we're just thinking about how many more times on top of 1 will it be in the same position as you rotate it around. Now the next part here, it says write down the number of lines of symmetry for this quadrilateral. So we're thinking about any mirror lines that we could draw on there where the reflection is the same either side of the mirror line. And hopefully you know your lines of symmetry fairly well, because hopefully you can see that if you were to draw a mirror line in here, it's exactly the same above and below. So it's definitely got one line of symmetry. Now it also has another line of symmetry where we're going straight down the middle. And there we go, that means we've also got another line of symmetry, so we've got 2 in total. Now sometimes people might think there are some diagonal ones, that's not actually the same there on either side of that diagonal, so you have to be very, very careful, but just make sure you get those obvious ones and then just see if there are any more. So this particular shape only has 2 lines of symmetry, where it's the same above and below that red line and left and right of that green line. So when we're looking at circles, there's 2 formulas that we need to know. Circumference equals pi times diameter, and area equals pi r squared. Remember the units for area have squared in, don't they? When we use centimetres, we have centimetre squared. So I always like to remember the little formula for area there is the pi r squared, the one with the squared in. So we're going to work out the area and the circumference of this circle. So to work out the area, we're going to do pi r squared if we start with that. So the area equals pi r squared. And we just need to know what the radius is. So over here the diameter is 8, so we're going to first halve that for the radius, so I'll just write r equals 4, and we've just got to type that in. So pi times 4 squared. 4 squared is 16, so it'd be pi times 16, and you can just write that as 16 pi. So if it asks you to give your answer in terms of pi, you can just do that, but we want to type that into our calculator if not. So 16 times pi will give us a decimal, which is 50 point. I'm going to round this, but obviously only round it if it says to in the question. It'd be 50.27 if I round it, centimetres squared, and that would be an area there to 2 decimal places. Let's have a look at working out the circumference. So circumference up here is pi times diameter. Now we've been given the diameter is 8, so to get the circumference, we just do pi times 8, and we could just say 8 pi. So we could just say 8 pi, which just means pi times 8. But again, if it asks us to work it out, we're going to do pi times 8 on the calculator. So 8 pi, press equals, and we get, and if I round this to 1 decimal place this time, I get 25.1. And circumference is a distance, it's around the outside, so it's just centimetres, 25.1 centimetres. But again, rounding it to how the question asks, and remembering you can write it in terms of pi, like down here 16 pi, and up here 8 pi as well. That same logic can be applied to a cylinder, so our cross section this time is a circle. So all we've got to do is work out the area of the circle, remembering area equals pi r squared. So working out the area of that circle, it's pi times 4 squared, which again is 16 pi we can write that as a decimal. Now what I'm going to do is I'm just going to leave it as 16 pi for the moment, so I don't have any rounding errors here, but you can write it as a decimal at this point, but I'm just going to leave it as 16 pi. Now once you've got the area of the cross section, you just times it by how far it goes through the shape, which in this case is this 15. So all I've got to do is times that by 15. So 16 pi times 15, which comes out as 240 pi, which is also a decimal, so it just depends on how the question wants the answer here. So it's 240 pi, or if I write that as a decimal, remember that S to D button or F to D button on your calculator, depending on which one you have, you get 753. I'm going to round it to 2 decimal places again, 0.98 centimetres cubed for volume, and there's the volume of my cylinder. So surface area of a cylinder is a little bit more complicated because we've got these 2 circles to work out, and then we've got this shape wrapped around the outside of the cylinder. So the area of the circle we've actually already worked out. Pi times r squared is 16 pi, and that equals the circle. Okay, and not forgetting we've got 2 of those, so let's times that by 2, which gives us 32 pi, which again is a number, but I'm just going to leave it till the end for the area of my 2 circles. Now the next thing that I have is this shape wrapped around the outside, and if we were to unravel that, we'd have a nice big rectangle, and the height of that rectangle there is 15. The length of the rectangle is actually the circumference of the circle. So we just looked at circumference of a circle. The circumference is pi times diameter, so I'll do 8 times pi, or 8 pi, the diameter there being 8, it's given us a radius of 4, so we could put the diameter equals 8, but that's 8 pi for the length. And we work out the area of a rectangle just by doing length times width. So to work out the area of this, we'll do 15 times the 8 pi, and that gives us 120 pi for the area of that rectangular part wrapped around the outside. All we've got to do to finish this off is add these 2 together, so we have 32 pi, add 120 pi, and in total that gives us 152 pi. Again, we could just write this as a decimal, but 152 pi comes out as 477.5 to 1 decimal place centimetres squared for surface area, and there's our final answer. So you just got to remember, you obviously got the circles top and bottom, and then to work out the area of the curved part, you need to think about that circumference there being the length of the rectangle. Next one here we have a hemisphere, and it says work out the volume of the hemisphere. Now again we'd be given the formula to work out the volume of a hemisphere, and volume of a hemisphere is 4/3 pi r cubed, and that is our final volume there. Oh, let's make sure that says, that's a rubbish 3, let's change that. 4/3 pi r cubed. So all you've got to do is stick the numbers in the formula again. So if I want to work out the volume, all I have to do is in the calculator I do 4/3 multiplied by pi multiplied by 8 cubed, and we'll get our answer here straight away. So fraction button, 4/3 multiplied by pi multiplied by 8 to the power of 3. And we get a volume here of 2144.66, again if I round it to 2 decimal places, centimetres cubed. Just remember obviously to write all the numbers down and only round it once you've been asked to. Okay, so once you've got your total volume of your sphere there, just remember this is a hemisphere, so it's half the size of a sphere, exactly half. So I just need to divide my answer by 2 here. And once we divide that by 2, we get a final answer of, let's have a look, 1072, so 1072.33. Again, I've rounded it there, centimetres cubed. And that would be your final answer here for the volume of a hemisphere. Not forgetting as well, you could be asked to work out the surface area. And if you're asked to work out the surface area, again, it gives you the formula of a sphere. And the surface area of a sphere is 4 pi r squared. So again, if I was to work out the surface area of this one, it's a little bit more complicated, but only in the sense that we work out the full surface area. So we do 4 times pi times 8 squared. If I just go for this, let's work it out. 4 times pi times 8 squared. That gives us a surface area of a sphere being 804, and it's 0.25 as well. Again, we'd have to halve it because it's half. Okay, so half of that would give us a surface area of 402.12. And that is obviously a surface area, so it's centimetre squared. But if you're working out surface area, you've got to make sure you don't forget as well the circle sitting on top there, because it's the total surface. And the area of a circle is pi r squared. So we can work out the area of the circle as well. And if we just do that, pi times 8 squared, we get an area of the circle there of 201.06, and you would just add these two numbers together to get the total surface area. So if you add 201.06, we get a total surface area of 102.12 added to that, gives us 603.18 centimetres squared. Again, so I know we were looking at volume there, but just thinking about if you had to do the surface area as well, how you'd approach that when you've got a hemisphere and you've got to make sure you halve them and add on the extra circle. Okay, so looking at trigonometry. Now the hint that we're going to be using trigonometry is we've got a right angled triangle and there's an angle within them. So looking at this one on the left to start with, because we're going to work out the missing length in these two triangles, I'm going to start with this one on the left. So we've got an angle of 43, and the only thing I have to remember here is how to spell SOHCAHTOA. So SOHCAHTOA. There we go. Now that's just going to help me to know which I'm going to use, whether I'm going to use sin, cos or tan. So the first thing I need to do is I need to label this triangle to see what sides we've got. So opposite the angle that we're using, that's called the opposite. The longest side, which is opposite the right angle, is always called the hypotenuse. And the final side there is called the adjacent. Now there's one of the sides here I don't need to be thinking about. I need to use the opposite. I'm looking for the hypotenuse, so I don't need the adjacent. So let's have a look at what formula triangle we're going to use. Well, O and H, opposite and hypotenuse, is within my sine triangle there, SOH. We've got O and H within that triangle, so I'm going to use SOHCAHTOA. The part of SOHCAHTOA I'm going to use is sine. Now the side that I'm looking for is the hypotenuse up here with the x next to it. So hopefully you're used to using formula triangles. I'm going to cover up the H. Okay, so the sum that I need to do to find the hypotenuse is O over S, or O divided by S. So that's O divided by sine. So to find the hypotenuse, I'm going to do the opposite, which is 6, and I'm going to divide it by sine. All I need to remember is to put the angle here, 43, with sine. So sine 43. So sine 43 tells me the relationship between the opposite and hypotenuse, and in this case we're going to do a divide. O on the top, S on the bottom. Don't forget to put 43 in the bracket there for some of your calculators. So 6 divided by sine 43 on the calculator, 6 over sine 43 is 8.79 centimetres. I'm going to round that to 2 decimal places, and it actually comes out as, if I write a few down, it's 8.7976. The question will tell you how to round it. So if I round it to 2 decimal places, that would be 8.8 actually, 8.8 or 8.80. Let's round it to 1 decimal place. So we've got 8.8 centimetres for that first question. Now if we have a look at the one on the right, so question 2, we've got a very similar process here. Let's have a look. So we still have a look at our angle, label the sides, so opposite that is our opposite. And then we've got the hypotenuse here. And again, the adjacent ends up being down the bottom based on where that angle is. Now again, we need the opposite because that's the one we're looking for. We need the hypotenuse because that's given to us, but we don't need the adjacent again. So again, I'm going to be using my sine triangle because I've got O and H. I'm going to rewrite it again. So I've got SOH, but this time we are looking for the opposite. So I'm going to do the same process again. I'm going to cross off the opposite, and that tells me that I'm going to do a times. I'm going to do S times H. Now S again stands for sine. I just need to put the angle with it. So this time it's 36. So sine 36, making sure you put it in a bracket again, times by the hypotenuse, which is here, which is 9. So sine 36 times 9. And again, typing that into a calculator, sine 36 times 9 gives me an answer of 5 points, and if I round it to 1 decimal place again, well, it comes out as 5.29. So to 1 decimal place, that would be 5.3 centimetres. And again, just thinking logically here about whether your answer makes sense, because it can't be longer than the hypotenuse there, so it can't be longer than 9. So you should know if you've done it wrong, because it might end up coming out longer than 9. So that's finding side lengths using SOHCAHTOA. When it comes to finding an angle, we've got a very similar process. I'm going to have a look at this question. It says find the sides of angle ABC. So from A to B to C, that gives us this angle down here. And again, I'm going to follow the same process. So opposite that angle is over here. Our hypotenuse is opposite the right angle, and our adjacent side is down here. So it looks like I've got a different bit of SOHCAHTOA to use this time, because this time I don't need the opposite, but I do need the hypotenuse and the adjacent. So again, just write down SOHCAHTOA. And we're looking for the formula triangle This time that has the h and the a in, the hypotenuse and the adjacent. So the h and the a is in my cos triangle, so I'm going to be using this one. Now we're looking for the angle this time, so if I cover up the angle part, which is the c, it tells me that I need to do a over h. Now if we just do that, a is 7 and h is 13. Now if I just type that into the calculator, 7 divided by 13 just gives me a decimal 0.538. Now the calculator doesn't know that this time I'm looking for an angle, so all I'm going to do to tell the calculator I'm looking for an angle is first I'm going to press shift and then press cos. So shift cos. And on your calculator it'll come up with, and let's get it on my calculator here, you get it saying cos -1. And that just tells your calculator, this time I'm looking for the angle, and this is the fraction I want to put in. So you type in cos -1, and then 7 over 13. And if your calculator has the fraction function, you can put it in as a fraction. If not, in the bracket there, just put 7 divided by 13. So let's do that. Cos -1, 7 divided by 13, or 7 over 13 is a fraction, and you get the answer here, 57.42. And if we round that to one decimal place, it'd be 57.4 degrees. There we go, for an angle. So it's the same process no matter which formula triangle you use. You just have to identify the sides, and then when you're looking for an angle, you're always going to press shift cos, shift sine, or shift tan, and you'll get this little symbol here, cos -1. Okay, so I've got a slightly more complicated question here. It says work out the size of angle BAD, and angle BAD is the full angle right here. Now that's going to be quite difficult for us to work out, but just like on previous questions here when we've looked at Pythagoras and trigonometry, we can chop this across the top, look, and that's going to be where we find our little right angled triangle. And if we chop this across, we now know part of the angle there, because that's a rectangle, so part of it is 90. So we just need to find out what this little angle is just here. And we can do that if we've got two of the side lengths. Now we've definitely got one of them, because we've got 15 down the bottom, so this must be 15 here, 15 metres. And we've got 6 along the top here. Now we know, because it's a rectangle with the 4 over here, that this must also be 4. So this little bit on top must be 2, because that gives us a total of 6 there. So now we've got our right angled triangle. We've got the opposite side over here, which is 2. So let's label that as the opposite. And we've got the adjacent side down here, which is 15. But again, we didn't need the hypotenuse, so we don't need to worry about the hypotenuse there. So we've got O and A, and that is again in our tan formula triangle, so TOA. And again, we're trying to work out the angle, so it's O over A when we cross out the T. So we go for tan -1, O over A, O being 2, the adjacent being 15, and if we type that in, shift tan, 2 over 15, and that equals 7.5946 with a few more decimals, or to one decimal place, that's 7.6 degrees, and that is the angle for the size of X there. Now this question obviously wants us to find the full angle BAD, so we've got the 7.6 in this little place here, which is a very small angle there, 7.6 degrees, and also the 90 degrees here that we've got in the rectangle. So adding them both together, 90 plus 7.6 gives us a final answer, which I'll write over here, of 97.6 degrees, and there is the final answer for our question there. Okay, so this question says a square has an area of 81 centimetres squared. Work out the perimeter of the square. Now when we're looking at perimeter, that's the distance all the way around the outside. So for a square, we know all the sides are equal, so we just need to find what the side length is of the square, and then we can add them all up. So if the area is 81, we're thinking what number times by itself, because we've got a length times width for the area of a square, is going to equal 81. And hopefully you can spot that that is 9. It's 9 times 9, which will give us an area of 81. When it comes to a square, you could actually just do the square root of 81. That's obviously figuring out what number times itself makes 81, and that would give you the answer 9. So we know the side length is 9, so to get the perimeter, we want all 4 of those 9s. We just want to add them all up. So you could do 9 times 4, or you could just write down 9 plus 9 plus 9 plus another 9, and that is equal to 36. And as it is perimeter, we want to give the units as a length, so that would be 36 centimetres. As our area was centimetres squared, Therefore, our length was also in centimetres. So there we go, that's our final answer, 36 centimetres. That's the perimeter of the square. Okay, so this question is slightly different. Not necessarily looking at a functional question, although it is the diagram of a floor plan. So it says here we have a floor plan, and the area of the floor is 138 metres squared. And it says work out the value of x, and x is this length down here. So in order to work this out, we're going to have to think about what we're actually missing and what information we have been given. So we've been told the total area. Now if we split the shape up, and again you could split this into either direction, if I split it across that way, then what could we work out? Well, we could work out the area of the larger rectangle on top. And we could then potentially work out the area of the rectangle on the bottom as well, but we're trying to find out what that missing length is. So if we go about trying to work this out, let's just have a think about what we'd get. Again, you could have split it going up and down, but we've just picked this one, so let's just see how this ends up. So for the top rectangle there, we would do the length times the width, which is 8 times 15. And if we work that out, let's see what we get. We get 8 times 15, and that comes out as 120 metres squared. So if that part is 120 metres squared, and the total area is 138, well, if we do 138 and we take away 120, that leaves us with an area left over of 18 metres squared. So looking at that bottom rectangle there, we have a width of 3. So what length would we need to have in order to get an area of 18? Well, we know it's going to be 3 times something, and that is going to give us 18. And hopefully you've spotted that that number would have to be 6. And again, you could reverse that by doing 18 divided by 3. So we know that this length down here is 6 metres. So now we should be able to work out that value of x, because this distance all the way along the top is 15, and we've got the part of that distance just here is 6. So if we do 15 take away the 6, it will tell us this remaining length here that's going to make it add up to 15. So 15 take away 6 would give us a length of 9. So the value of x must be 9, and that is already in metres, so x is equal to 9. And there we go, that would be our final answer. So as you can see, sometimes with these compound area shapes, you would have to work out a missing length by thinking about that in a different way. And that's just another method for some of these compound area questions. Okay, so working out the size of angle x, again I've got 2 here, and we're looking at parallel lines. As you can see by these arrows here, these lines are parallel. So there are 3 rules that we're going to really look at when we're looking at parallel lines, as well as all our normal angle rules. We've got alternate angles, corresponding angles, and co-interior angles. So if we look at this one on the left here, 110, there's lots of angles we can find now. So all around this point here, we can find all of these angles. Vertically opposite the 110 is also 110, and then next to the 110 on the straight line there, remembering angles in a straight line add up to 180, these would all be 70. There we go. So it's up to you really how you actually find this final one. I'm going to have a look at finding this Z shape here, which is an alternate angle, and alternate angles are equal. So this 70 here is the same as this 70 here. So x would equal 70 degrees in this one. And we've normally been asked to give our reasons there. So my reason may have been angles on a straight line equal 180, and that's how I got the 70. And then I would have said alternate angles are equal, and that's really important the way you say that. So alternate angles are equal. Okay, there are also other ways that I could have done that. If I flick to another colour, we could have said, okay, well if this is 110, well then this here is also 110, because those angles are corresponding. And again, I'll try and draw this on a different colour, but they make this F shape, okay? So that 110 and that other 110 are corresponding angles. So we could have done it that way and then done angles on a straight line. Let's have a look at this other one. So 105 degrees down in the bottom here. So straight away, just above that, we can find that this angle's 75, because angles on a straight line equal 180. Now, if you have a look, we've got a triangle in this question. Now, there's these 2 symbols here, which tell us that this is an isosceles triangle, and base angles in an isosceles are equal, and it's underneath these 2 little, what I call little eyebrows. Okay, so underneath, this will also be 75, because base angles in an isosceles are equal. We can then find this missing angle here, because angles in a triangle equal 180, so those 2 75s equal 150, and if we take that away from 180, it leaves us with the other angle in that triangle being 30. There we go. And there's all the angles that we found just using basic angle facts. Now to get that angle x, there's a couple of ways we could do it. We could find this angle here, and then do angles on a straight line, Or we could again identify that actually we've got one of these alternate angles going up, making this Z shape again. So that's an alternate angle with the 30. So that's 30 degrees as well. So for this one, we'd say x equals 30. And again, we'd probably give this same reason over here that alternate angles are equal. Unless, of course, we took a different approach, which we could have done. Again, lots of different ways that you can tackle these questions, but a few there that you need to make sure that you try and remember. Okay, so a slightly different question here. We've got some negatives in our vectors. We've got a negative on the top of A and a negative on the bottom of B. So that indicates a left movement of 2 there for vector A and a down movement of 1 for vector B. And it wants us here to write down 2A minus B as a vector. So we're going to do the vector 2A. So let's do that one to start with. We've got 2 lots of, and then we have minus 2 and 5. And we're going to take away from that vector B, which is 3 and minus 1. Okay, let's sort out this 2 lots of vector A to start with. So doubling both of those, we have minus 4 over 10. Okay, so just doubling those, and we're going to take away this 3 over minus 1. Now we're going to deal with the top numbers to start with. So let's just think about this numerically. We've got minus 4, and we're going to take away this time, we're going to take away 3. So minus 4, take away 3, leaves us with minus 7. And on the bottom there, we just need to be careful because we're going to be doing 10 and we're going to take away that negative 1 on the bottom. So taking away a negative, that's obviously going to add 1. So actually we're going to do 10 add 1 here, and that's going to be 11. And there we go. There is our final vector, minus 7 over 11, written as a column vector. Okay, so for these next few questions, we've got some visual vectors that we can actually see drawn on the grid. And it says in the question here, the vector A and B are shown on the grid. And we've got vector A that we can see there going sort of upwards to the right, and vector B that we've got going downwards to the right as well. And it says for part A here, on the grid, draw and label the vector minus 2A. Now obviously 2A will just be double the distance of A. The fact that it's put a minus in there means it's going in the opposite direction. So instead of our arrow pointing upwards, it's going to be kind of coming downwards to the left. So in terms of looking at this, we just need to establish what the pattern is of A just to make sure that we draw this in correctly. And you can kind of see if we start from a certain point, we need to go across 1 and we go up 2. There we go, let's draw that again. So we go across 1 and we go up 2. Right, so in terms of actually getting the pattern here, we just need to pick somewhere, hopefully not somewhere where it's going to overlap with A. So let's start down here. There we go. And we're going to go across 1 up 2, which gets us to there, across 1 up 2 again, and that will get us to there. Okay, so let's rub that out. So in terms of actually drawing the line in, that would be the vector 2A, double the distance of A and following that same pattern across 1 up 2. The fact that we're doing minus 2A just means we need to point the arrow in the opposite direction. So there we go, we can label that. That would be the vector minus 2A. And there we go, there's part A done for that one. Now for the other one, we've got to work out the vector A plus 2B as a column vector. And the process of looking at the pattern is really going to help us for this. So we looked at the vector A to start with. Now that vector A, and we can write this down over here, the vector A, it went across 1 and up 2. So that would be 1 in the positive right direction, and then 2, obviously being a positive in the moving upwards. So there's our vector A, 1 over 2. Now the vector B, let's have a look at that one. So from the start, obviously it's going downwards, this one, as shown by the arrow. That's going to go across 1, so a positive 1, and then it goes down by 3, so that'll be negative 3. So the vector B, if we write that in, B is equal to 1 over minus 3. So now we've established that, we can just treat that like we did in those earlier questions. We're going to do an A, and we're going to add to that 2 B's. So in terms of writing this one out, we've got A, which is 1 over 2, and we're going to add to that 2 of the B's, so that's going to be 2 lots of 1 on the top, which is 2, and 2 lots of minus 3 on the bottom, which is minus 6. There we go, and we can add those together, so 1 plus 2 on the top gives us 3, and then 2 add negative 6 on the bottom. Well, when we add negative, that's going to take that away, so that'll be minus 4 on the bottom. So our final vector will be 3 over negative 4. And there we go, that's how we're going to approach these vectors when they're on a graph. Obviously we can just turn the vector into a column vector and treat it just like we did on the previous questions. Okay, so here we've got 60 people each took a driving test one day. 21 were women, 18 of the 60 people failed, 27 of the men passed their test, 1 of the men is chosen at random. What's the probability this man failed his test? Now this is a little bit nicer to draw a frequency tree because we only have 2 options here. We have men and women, and then whether they pass or fail. So the trees are actually a lot nicer when it's just the 2. Well, let's have a look. We've got men and women, and then off each of those branches they either pass or fail. I'm just going to put P for pass and F for fail. There we go, and there's the tree. And there we go, so pass, fail. So if we go about filling in the information we've got, then we've got 60 people took a driving test, so 60 at the start. 21 were women, so 21 down here. 18 of the 60 people failed their test. So let's have a look. 18 of the 60 people failed their test. So we've got these two here in failed, and that has to add up to 18. So 18 of them are going to fail. We don't know whether it's male, men or women yet, but 18 failed. Then it says 27 of the men passed their test. So up the men, 27 passed. There we go, that's that one. Right, okay, so that's all the information that we've got. Now we know that there are 21 women, so we can work out how many men there are. They have to add up to 60, so that's going to be 39. There we go. And now we can work out this one just here, because it's got to be 39. We've got 27 in there already. So that is an extra 12. Okay, just double check they add up to 39. Yes, they do. Now we can deal with this bit of information. Look, these two have to add up to 18. We've got the one of them there is 12, so this has to be 6. And then these two here have to add up to 21. So we've got 6 in that one at the moment. So that's an extra 15 there to make sure that adds up to 21. Now we can take the same approach as before. It says one of the men is chosen. Work out the probability that this man failed his test. So one of the men, so it's out of these 39, and 12 of them failed. So there we go, we've got 12 that failed out of the 39 men. There we go, and there's our probability. Right, okay, so that is how we deal with this using a frequency tree. Okay, the table shows the probability of picking different colours. So we have red, blue, white and black, and it says the probability of white and black is the same, complete the table. So at the moment, we've got these two which add up to 0.7, and probabilities have to add up to 1. Now what we've got left over there is 0.3. I like to think of it as 0.30 because if they're both the same, we're going to have to halve that, and half of 30 is 15, so it's 0.15 for both of those, and now they add up to 1. Now for part B, it says that there are 60 counters in the bag. How many are white? Now if we look at the probability of white, which is over here, 0.15 is 15%. So really all this is asking us to do is to work out 15% of 60. And we can do that nice and easy. 10% is 6. 5% is half of that, which is 3, and add them both together, and that's 9. Now part C here, you won't be given this at the same time as question B because we already know that there are 60 counters in the bag, but it says that there are 12 red counters, and how many counters are now in the bag. So if we imagine this is a completely different question now, but it's saying that red counters here, which is 20%, is now 12 counters. So all that's actually saying is 20% equals 12 counters. Now that's okay, we can turn that back into 100% quite nice and easy. I could just times that by 5, but let's imagine it's not a nice percentage. I'd have to try and break it down to something which turns into 100. So we could divide it by 2, which would give us 10%, which is half of 12, which is 6, and then times that by 10 to get us back to 100%. Okay, again, you could actually just times 20% by 5, but I think that's quite nice just to break it down and build it back up. So 60 counters there would be in the bag. Okay, so we've got a lot of information here. 100 students are in a year group, and then we've got some information about whether they wear or do not wear glasses. And it wants us to work out the probability of choosing a boy who wears glasses. Now, when you've got a lot of information like this, I like to organise it in a two-way table. So I'm going to put this all into a two-way table. Again, you could use a frequency tree, but I'm just going to opt for using a two-way table. So we could have boys and girls on the side. Again, you could have them at the top, but I'm going to put them to the side. And then you've got a total down the bottom. And then we've got whether they wear or do not wear glasses. And again, we've got a total here. So what I'm going to do is put the numbers within the question. We've got 100 students in the year group. 42 of them are boys. 8 out of 100 students wear glasses. So 8 students here wear glasses. And 52 of the girls do not wear glasses. So 52 just here. Now that's everything in the question. We've just got to fill in all the missing numbers now. So if there are 42 boys here, that must mean that there are 58 girls. And out of those, 52 do not wear glasses. So that must mean that 6 of them do. Now again, we've got 8 that do wear glasses, 6 of them are girls, so 2 boys must wear glasses. And again, going along this way, that has to add up to 42, so that must be 40. And then moving downwards or across from another direction, I could add those together to make 92. And a very quick check here, those two add up to 100, so that's right, we're happy with that, we can tick that off. Now it says, work out the probability of choosing a boy who wears glasses, and one of the students is picked at random. Well, 2 of the boys wear glasses, so that would be 2 students out of the 100 students that we've got here. You don't have to simplify that, but just a quick note, it could have said in the wording here, it could have said, rather than saying one of the students, it could have said one of the boys. Now if it had said it, maybe it had picked one of the boys, then that would have been out of 42. So it would have been 2 over 42. But it just depends on what the wording says. So it does say one of the students. It doesn't dictate whether it's boys or girls, so it's out of 100. Okay, so looking at a line graph, it says in Adam's garden, the flowers are only red, white, yellow or blue. And you can already see on the graph here, we've got red, white and yellow, but we're missing the blue. So it says the chart shows, and obviously just what I've said there, it shows the number of red, white and yellow. And this is the total number of flowers is 30. So the total number is 30, work out the number of blue flowers. So we want to work out from this graph how many are red, how many are white, how many are yellow, and we'll figure out the difference there to see how many are blue. So you can see red, if we go across, falls on 8, so there are 8 red, so we'll put 8 there. We go across from white, and that lands on 10, so 8 plus 10. And then if we go across from yellow, that's in between 4 and 6, that's going to be 5. So we've got 8 plus 10 plus 5, that adds up to 23. So we know that there's a total of 30. So if we do 30, take away the total of red, white and yellow, which we've worked out to be 23, that leaves us with 7. So there must be 7 blue flowers, as it does say in that first line there, only red, white, yellow or blue. So all those remaining flowers must be blue, and therefore our answer is 7 blue. Okay, so this is a relatively tricky question, but it's asking us to work out the mean from a graph. It says here that Fran asked each of 40 students how many books they bought last year. Show that an estimate for the mean number of books bought is 9.5, and you must show while you're working. Now normally when we're working out the mean and we have these sorts of bits of data down here called grouped data, we'd normally put that in a table. So we would normally write, I'm going to draw like a pretty basic table here, but we would normally say sort of like 0 to 4, I've always written 0.4, let's just change that, 0 to 4, that's our category, I'm going to write it again, 0 to 4, and then we've got 5 to 9, 10 to 14, 15 to 19, and we've got 20 to 24. And normally when we are doing mean from a table, when we've got grouped data, we do the midpoint and times by how many there are. So for each one of these bars, we want to figure out how many there are, so we can actually go about doing that. So for the first bar, we're between 10 and 12, so that's 11. There we go, so we've got 11 books between 0 and 4. 11 people that bought books between 0 and 4 books. For the next one, that lands on 8. So 8 people that had between 5 and 9 books. For the next one, that's between 12 and 14. So that's 13 people that had between 10 and 14 books. For the next one, there we go, we've got 6 people between 15 and 19 books. And for the last one there, we've got only 2 people that had between 20 and 24 books. So that's all the data that we've got from the table. Now we want to actually go about finding mean from a table just in a way that we normally would. So we'll take the midpoint, so I'm going to write those in. So the midpoint of this one is 2, the midpoint of 5 to 9 is 7, from 10 to 14 is 12, from 15 to 19 is 17, and for the last one there from 20 to 24 is 22. So we're going to multiply that midpoint by how many people there were, and that will give us our total, or an estimated total. So 2 times 11 is 22. Obviously don't forget, you have got a calculator for this, so you can always work these out on the calculator. 7 times 8 is 56. You've got 12 multiplied by 13, which is 156. There we go. You've got 17 multiplied by 6, that's 102. And then you've got 2 times 22, which is 44. So that's our estimated amount of books that people have had. So if we look at this then, we want to add all of those together to get our total. So again on the calculator, we've got 22, add 56, add 156, add 102, and then add 44, and that gives us an overall total of 380. Now, a big mistake that people make is they divide that by how many groups there are. So they might divide that by 5, but of course we want to divide by how many people there are. And in total, and we were told in the question, there are 40 students. So we would divide that by 40. So 380 divided by 40, and that gives us an answer, again on your calculator, of 9.5. So there we go, that's shown that that's 9.5. So this is a very unique question. We are finding the mean from a graph, but because it was grouped data, as we can see from the bottom there, we have to find the midpoint and then multiply that across to get our estimated totals and then find our estimated mean. So there we go, that is the answer to that question, and a useful video to watch on that would be averages from grouped data. Okay, that is the end of the video. Well done for making it to the end of this series, looking at the AQA Foundation topics. Don't forget to check out the other videos in the description for paper 1, paper 2, and obviously this one being paper 3. Hopefully that was useful and helpful. If it was, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you for the next one.